Hello, everyone. Today we're going to be talking about AWS network architecture and the simplest way to guarantee uptime for your applications. We'll walk through key building blocks that make the cloud networks secure, reliable, and scalable. First, let's start off with some foundational concepts. When we talk about the AWS infrastructure, we need to understand two important terms: regions and availability zones. Think of a region as a separate geographical area like US West or US East. Each region is completely independent from the others. Within each region, AWS has multiple isolated locations called availability zones, or AZs for short. Here's what's important to know. Amazon EC2 lets you place your resources and data in multiple locations. But here's the catch: resources aren't automatically replicated across regions unless you specifically set them up that way. Now, some AWS services handle multiple availability zones natively. For example, RDS and S3 supports multi-AZ deployments right out of the box, but they don't automatically span multiple regions. Similarly, VPCs can stretch across multiple availability zones, but they are limited to a single region. Now let's talk about Virtual Private Cloud, also known as VPC for short. This is your own private network within AWS. A VPC lets you provision a logically isolated section of the AWS cloud where you can launch resources in a virtual network that you define. You have complete control over your networking environment. You choose your own IP address ranges, create subnets, and configure route tables and network gateways. VPCs can both have public subnets or private subnets. In our setup, let's focus on private subnets, which means no internet access in or out by default. The main purpose is creating our own private network that's completely inaccessible from the internet. Now, how do we connect our VPC to the outside world? That's where the internet gateway and routers come in. Think of this as a software based firewall and a router, just like the hardware router you might have at home, but easily configured in the cloud. The Internet Gateway connects your VPC to the Internet. It allows public routing of IP addresses and load balancers inside your VPC. The router, on the other hand, directs traffic to the right destinations, typically to specific subnets based on your routing rules that you define. Now, let's talk about distributing traffic effectively and efficiently. The Elastic Load Balancer automatically distributes incoming traffic across multiple EC2 instances. Now, here's what makes it especially powerful. It detects unhealthy instances and automatically reroutes traffic away from them. It also scales its request handling capacity up or down based on incoming traffic. You can use elastic load balancers to distribute network load efficiently between multiple availability zones for maximum reliability, or between multiple machines within a single availability zone for better performance. Try say availability zone fast 3 times. Next, we have an elastic IP address. Elastic IP is simply a static reusable IP address designed for dynamic cloud computing. What makes it special is it's associated with your AWS account, not a particular instance. This means you can quickly remap the address to another instance if something fails, make effectively masking failures. The IP remains with your account until you explicitly release it. We use elastic IP addresses to create external DNS accessible routing and allow public internet access to our resources. Next, we have Bastion Instances. Security is so crucial in this case. This is a special purpose computer on your network that's specifically hardened to withstand attacks. It's just another EC2 instance, but it's configured to run minimal services, typically just a proxy server to reduce potential threats. The Bastion sits on the outside of your firewall or in a DMZ, providing controlled access from untrusted networks. We use Bastion instances to allow secure VPN tunnels for developers and administrators, and to connect multiple regions via encrypted tunnels. The NAT instance stands for Network Address Translation. Your home router does the exact same thing. Now, here's the problem it solves. Instances in a private subnet can't communicate with the internet directly. A NAT instance, which sits in a public subnet, enables those private instances to initiate outbound traffic to the internet while preventing inbound traffic from reaching them. It's just another EC2 instance running software that allows computer inside of your private subnet to connect to the internet and access resources like S3 that are in a public space. Let's clarify what a subnet is. A subnet is a logically visible subdivision of an IP address. I'll say that again. A subnet is a logically visible subdivision of an IP address. When you divide a network into multiple networks, this is called subnetting. Traffic between subnets is routed through routers, which form the boundaries between them. Essentially, subnets divide IP addresses to establish rules for traffic routing. There are two types of subnets: public subnets, which are visible from the internet, while private subnets are not. This lets us easily route traffic correctly. For example, sending outbound traffic through a NAT instance while keeping internal resources protected. Now, we're going to go into single region multi-AZ topology. In this diagram, we're taking a look at real architecture. It shows us a single region, US West 1, with two availability zones. Each availability zone contains application servers, web servers, and NAT instances. We have a master database in one zone and a slave database in another for redundancy. Both zones connect through NAT instances to an internet gateway. Notice the different connection types. Standard network traffic flows in blue, while encrypted tunnels connections appear in green. This setup provides high availability. If one availability zone fails, the other keeps running. Next, we're going to take a look at multi-region topology. This takes things a step further. It shows a multi-region deployment spanning across US West 1 and US East 1. Each region has its own complete VPC infrastructure with app, NAT, and web components. The region connects through a central internet cloud and uses encrypted IPsec tunnels for secure communication. Notice the database setup. US West 1 handles read and write operations, while US East 1 handles read-only operations. This provides disaster recovery capabilities and lets users access data from the closest region for better performance. Next, we're going to take a look at a single AZ multi-subnet topology. So, the private subnet contains our application and our web servers protected behind a load balancer. The public subnet contains the NAT gateway and security devices. Private resources must go through the NAT gateway to reach the internet, which keeps them secure while still allowing necessary outbound connections. This architecture demonstrates defense in depth, multiple layers of security, protecting your critical resources while maintaining the connectivity that you need. So, there you have it, the key components of AWS network architecture by combining VPCs, subnets, load balancers, NAT instances, and multi-AZ deployments. You created a network that's secure, scalable, and highly available. This is how you guarantee uptime in the cloud. Thank you for your attention, and I hope you enjoyed this presentation.